Hello. Today I want to go over some topics that have to do with hypothesis testing. And we know that there are two kinds of errors we can make. We can make a type 1 error, which is to reject a true null hypothesis, or a type 2 error, which is to fail to reject a false null hypothesis, or a whole new concept, the power of the test, which gives me the probability that I reject a false null in favor of a true alternate hypothesis. Long ago, you learned that the probability of a type 1 error was alpha, and the probability of a type 2 error was beta. And you did not learn, but you will today, that the power of the test is just 1 minus beta. So I think these are all most understandable in terms of a diagram. So let's draw a familiar diagram and see where alpha and beta and the power of that test all come into play. So I'm drawing a nice long axis here. And let's suppose that under the null hypothesis, my mean is right here on this axis. And so that mean gives me a probability distribution. It wouldn't have to be a normal, but I'm going to assume a normal as I draw this little sketch because you're familiar with the normal and because it's easy to draw. That's kind of a funky little normal, but there's a normal distribution for us. Now suppose that it's an upper tail test. Then my alpha, my critical region, would be in the upper tail and would be an area right above the critical region. The critical region is right here on the horizontal axis, and the area right above it would be an area of alpha, and that is my probability of a type 1 error, because if this is the true distribution for my test statistic, it's the distribution given by H naught, then any time that my test statistic falls in this orange region, I'm going to reject H naught. That's rejecting a true null hypothesis, and that would happen with the frequency of alpha. Now let's pick a hypothesis that we will call the alternate hypothesis, and that hypothesis would give us a value of the null, of the mean, and maybe the distribution would look something like this. So given a particular alternate hypothesis, the green is the distribution. The alternate hypothesis is telling me that mu, and I'll put a little HA on it so we can tell it from the other mu, that mu HA lives right here. The probability of committing a type 2 error is the failure to reject a false null hypothesis. If the null hypothesis is false, and if the green alternate hypothesis is true, you know the decision that would have me fail to reject H naught would be a value of a test statistic that falls anywhere in this region that I'm underlining now. Anywhere in there, and I'm going to accept H naught. Well, the probability of that happening, if HA is actually the true value of the distribution of our test statistic, the probability of failure to reject H naught would be the area, the measure of the area right in here. So this area would be beta. That's the probability, as it says here, that I fail to reject a false null hypothesis. And why would I fail to reject a false null? If the null is false and this is the alternate, then the probability that my test statistic falls anywhere under here is the blue area under the alternate hypothesis. And so there's a probability beta that I would get a test statistic that fell in here, and that would lead to the decision to fail to reject the null H0. Now what about the power of the test? The power of the test is the probability that I reject a false null in favor of a true alternate. If this is my true alternate, what's the probability that I reject this null hypothesis? Well, if this is the true alternate, I'm going to reject the null hypothesis if my test statistic falls anywhere above this value right here. If it falls above that value, we say it's in the critical region for testing H0, and we would reject the null hypothesis. But if the alternate is really true, the probability of falling up here is a whopping big area. I want to pick a nice color. It's a whopping big area, and I'll shade that area horizontally. And so this, I'm shading in right now the probability that when HA is true, that I detect that it's true. That is, given that HA is true, the area that I'm shading right here is the probability that I'm going to reject the null hypothesis in favor of HA. Now that's all the area under the green curve, the alternate, except for this piece that we've cordoned off over here, except for beta. So this area has got to be everything that's left, namely 1 minus beta. And that's called the power of the test. And it's the ability or the probability that this test will find in favor of HA when HA is true. And you can see that these values play off of each other. If I want to make the probability of a type 1 error smaller, then I have to make alpha smaller. To do that, I'm going to have to move this critical value that we've indicated right here, I'm going to have to move that to the right. But as I move it to the right, alpha gets smaller. Notice the beta is going to get larger, and the power of the test, the 1 minus beta, is going to decrease. And you can play around with several things here. If you want beta to be smaller, then you're going to have to move this value in this direction. Whenever you do that, beta, sure enough, will become smaller, but alpha will become larger. So these things play one off the other. And I hope that gives you some insight into the role of alpha and beta and the power of the test. Thank you.